This is Hitul Arora.
And I am Natasha. This is ELL212 assignment 2. In this video, we'll be talking about application of EM waves in radar and its basic working principle. Radar is an object detection system that uses radio waves to determine the range, angle, or velocity of objects. The term radar was coined in 1940 by the United States Navy as an acronym for radio, detection, and ranging. Working principle of radar: transmitter transmits EM wave which gets reflected from the target. This reflected wave is received by an antenna that extracts desired reflected signals. So this is the diagram showing the basic working of the radar.
After the reflected signal is received, range or distance can be determined by measuring the total time it takes for the radar signals to make the round trip to the target and back. The angular direction of a target is found from the direction in which the antenna points at the time of receiving. The speed of the target can be determined from the change in the frequency of received signals due to Doppler effect. Distance measurement. As discussed before, we can use the time of flight to measure the distance. The distance is one half of the product of the round trip time and the speed of the signal. Speed measurement. Since speed is the change in distance with respect to time, the existing system for measuring distance combined with the memory capacity to see where the target last was is enough to measure speed. Another effect that can be used to make almost instant speed measurement is the Doppler effect. The Doppler effect is only able to determine the relative speed of the target along the line of sight.
This is the basic block diagram showing various components of a radar system. First major component is transmitter. It produces the short duration high power radio frequency pulses of energy that are radiated into space by the antenna.
The next major component is duplexer. Since most radar systems do not transmit and receive at the same time, a single antenna is often used on a time-shared basis for both receiving and transmitting. The duplexer alternately switches the antenna between the transmitter and receiver. The next component is receiver. The receiver amplifies and demodulates the received RF signals. The receiver provides video signals on the output. Another important component of the radar is the antenna. The antenna transfers the transmitter energy to signals in space with the required distribution and efficiency. This process is applied in an identical way on reception. The display. The display should present to the observer a continuous, easily understandable graphic picture of the relative position of radar target.
Let's come to the application of electromagnetic waves in radar. Reflection of electromagnetic waves. Electromagnetic waves are reflected by the target. If these reflected waves are received again at the place of their origin, then that means an obstacle is in the propagation direction. These are less prone to disturbances. The frequency of electromagnetic energy used for radar is unaffected by darkness and also penetrates fog and clouds. It permits to determine the position of airplanes, ships, or other obstacles that are invisible to the naked eye because of distance, darkness, or weather. EM waves travel at constant speed. This constant speed allows the determination of distance between the reflecting objects and the radar side by measuring the running time of the transmitted pulses. This energy normally travels through space in a straight line and will vary only slightly because at atmospheric and weather conditions. Using spatial radar antennas, this energy can be focused into a desired direction, thus the direction of the reflecting objects can be measured. These are the references.
Thanks
Thanks
for
for
watching.
watching.